So today we're going to go through 6 examples on trigonometric substitution so that you can master it. So let's try to look at the first one. So this one, so you can see that there's no square root, but actually we can still use trigonometric substitution to do it, especially because it matches the form inside the second one, square root of a squared plus x squared. So let's try to see how we can do it. So let x equals to a tangent theta, where a squared equals to 1, so that means a is 1. So x equals to tangent theta. So dx will be secant square theta d theta. Okay, so now let's try to substitute everything back in. So we will have integrate 1 over. So x is tangent theta, so it will become tangent square theta, and then plus 1. And then our dx is now secant square theta d theta. So you see how we can proceed. You can see that in the denominator we have 1 plus tangent square theta, which we know that from Calc 1, this is just secant square theta. So this further simplify to secant square theta divided by secant square theta d theta. But what is this guy? It's just 1 because the numerator and the denominator are the same. So we're just integrating 1 d theta. So we know that the answer is just theta plus c, of course. So the question is, are we done yet? If you look at the original question, remind yourself we are in the dx world, right? Because the question is giving using the variable x. But now your answer is actually in theta. That's because we made a substitution. So now what we need to do is to substitute it back. I just see Stormy sleeping there. Okay, so how do we find theta when we have tangent theta? So that's quite direct. So we know that we can actually take arctangent on both sides. So the inverse function, they cancel each other. So what is theta? That will be just be theta. What's left will be just theta. So now we know that theta will be arctangent of x. So if we substitute back into our solution, that's our answer. So you may actually, at this point, you may realize that they're actually quite familiar, this result. And indeed, yes, because in Calc 1, we actually learned that the derivative of arctangent will give you 1 over x squared plus 1. So if you want to check this result, we can actually do a very quick calculation. So let y equals to arctangent of x. So what are we looking at? We want to find dy dx, right? So but we don't know how to differentiate inverse tangent. So let's try to do the same trick, and then we do tangent of y equals to x. And now we can actually differentiate both sides with respect to y. So let's try to write out this step. So using some first principle calculation, we actually know that the derivative of tangent is actually secant square. And then equals to dx dy. So now we know that dy dx, we can just take this reciprocal, will be cosine square y. So, but this is not what we want, right? We want a derivative to be in terms of x. So how can we fix this? So the answer is actually very simple. We do the same trick where we draw a right angle triangle. So if we look at this expression, it actually tells you one thing. Tangent of y, so that means y is the angle, and then we have right angle here. will equals to x. So what is tangent is the opposite side divided by the hypotenuse, divided by the adjacent side, right? And what is x? X is just x divided by 1, right? So that means we have x and 1 here. So using Pythagoras theorem, we know that the hypotenuse will be just 1 plus x squared. Okay? So now cosine square y will simply be, what is cosine? Is 1 over the square root of 1 plus x squared, and then we take the whole square. So this guy will equals to simply 1 over 1 plus x squared. So you see, it matches the original integrand. So that means our calculation has been verified and is correct right now. So this example is interesting in the sense that like we actually need to exact the same trick here. When you recall when we just learned it today, we need to use the right angle to find the sine, cosine, tangent, and you realize that besides integration, differentiation, sometimes we also need to use the same trick. So this one is a very easy example because when you convert the stuff into the theta world, right? You see everything is originally in x, and then I try to substitute everything back into the theta world. And you see that we're integrating a very simple function 1 here. So that's why this particular example is a good example for beginners to get a little taste of what is trigonometric substitution. So now let's go to the second example. This example is quite interesting because without trigonometric substitution, you should be able to find this integral like very quickly and easily by the definition of definite integral. So can you tell me what does the graph looks like of y equals to the square root of 4 minus x squared between x equal to 0 to x equals to 2? So let's try to square the equation. So y squared will be 4 minus x squared. So x squared plus y squared is equals to 4, which is just 2 squared. So essentially, if you graph it on the xy plane, you have from 0 to 2, you actually have a quarter circle of radius 2. So because of the fact that definite integral is essentially area, right, is sine area, we can actually calculate this area very easily using some high school formula. So the area will be pi r squared. This is the full circle, but because we only have a quarter of it, so we have 1/4. So which is 1/4 pi 2 squared, which is just 4. So the answer is just pi. So we should be able to calculate this answer, and then we can verify see if it's pi. So how can we do it? So if you look at the table, some number minus x squared is essentially the one in the first row. So we'll use that. Okay. So and especially what is 4? 4 is just 2 squared, right? So now I know that this is how I make my substitution. Let x equals to 2 tangent theta. Sine theta. Okay. So now dx will be 2 times, what's the derivative of sine? Cosine. And then times d theta. So now we can substitute every back in. So this guy will equals to 4 minus, so what is x? X is just 2 sine theta, right? So that will be square, so it's 4 sine square theta. And times, what is my dx? Dx is just this guy, right? So do we have 2 cosine theta d theta. And you will see that we actually have a definite integral, so that we actually have the top and bottom. So you know what? Let's try to forget about it. Okay, so forget about it for now, or not forever. Okay, we will plug in. We will first find the antiderivative, and at the end we will plug in 0 and 2 for the lower bound and the upper bound. Okay, so now we drop the limit first. So this guy, 4 minus 4 sine square theta, you can actually factorize the 4 out. 1 minus sine square theta times 2 cosine theta d theta. Okay, and we know that 1 minus sine square is essentially just cosine square. So if you take 4 cosine square theta and then you take the square root, you have 2 cosine theta. And then of course you multiply by 2 cosine theta d theta. So we have 4 integrate cosine square theta d theta. And this one, we need to use another trigonometric identities, which is the double angle formula for cosine. So integrate 1 plus cosine 2 theta divided by 2 d theta. So 4 divided by 2 is just 2, so I integrate 2. And then the integrand, we can actually calculate it immediately. So integrate 1 plus cosine 2 theta d theta, which will be the integral of 1 is just theta, right? And then the integral of cosine will be sine, but we need to have the 1/2 because of there's 2 theta in it, okay? 2/2, and then sine of 2 theta. So now, again, we can plug in the values of theta, but this time, do we have theta? No, remember, these bounds, they are actually x, right? So let's try to calculate the corresponding theta value. So let's copy it. We have x equals to 0 and x equals to 2, right? So if we plug in the equation, we have 0 equals to 2 sine theta. So sine theta is 0. So when the sine theta will be 0? When theta is 0, right? So the lower bound in theta will become theta equals to 0. How about the other one? So again, we plug in x equals to 2. So we have 2 equals to 2 sine theta. Okay, so that means sine theta will be 1. When the sine theta become 1? When theta equals to pi over 2. Okay, so now we can plug in these values back into the antiderivative that we just found. So from 0 to pi over 2. So that will equals to 2 times pi over 2 plus 1/2 sine of 2 times pi over 2 is just pi, minus 2 times 0 plus sine of 0 is just 0, right? So what is also sine pi? Sine pi is also 0. So the answer is just pi, which matches what we just talked about at the very beginning. We can actually verify the result using the geometric formula this time. Okay, so let's go for a third example. So this one, again, you see square root of something, and then you have x squared minus 1, which is 1 square. So if you look at the table, that will match us the third row, okay? So we would pick x equals to a secant theta. So let's try to do that. So let x equals to a is just 1, so we just secant theta essentially. So dx will be secant's derivative will be secant tangent, right? Secant theta, tangent theta, d theta. So let's try to put it here. So now we can substitute everything back. So for trig integral, I always say that there's three parts. You have the culprit, like all the troubles is actually because of the square root, and then square root makes life more difficult. And then we have the surveillance, just some expression about x, which is nice. And also with the differential that need to go back to the theta world. So let's just do them one by one. So the first guy is the culprit, okay? So that will be just secant square theta minus 1, right? Because x is secant theta. The second guy below x, nothing fancy. So what is x? Just secant theta, right? Lastly, dx will be secant theta tangent theta d theta. So, again, we're using our trigonometric identities. We know that what is secant square theta minus 1? That is just tangent square theta. Okay, so now let's just erase the square root and the square. They eliminate each other. So we can do some eliminations. So secant and secant, they cancel out. So we have just tangent square. So now you need to remember how to... They are sleeping and looking at each other. Oh. Oh my god, they're so cute. They are Rocky and Stormy. Rocky on the left, Stormy on the right. So if you forget how to integrate tangent square, we have a very particular trick. So we use the identity again. So tangent is actually secant square theta minus 1 d theta. And we know, okay, what is the integral of secant square? We know that it's a very nice function. It's actually just tangent theta. And then 1, after you integrate, it becomes theta plus c. And so again, remind yourself, this particular integral here requires this particular usage of the trigonometric identities. And then we also know that, the derivative of tangent is secant square, so that we can immediately get the antiderivative. So now, again, we have one more thing to do, because we are given an integral in x, but now we are having things in theta. So again, we need to convert things back into the x world. So let's try to draw some triangles. So with x equals to secant theta, so let's mark this angle as theta. What is secant? Secant is actually 1 over cosine. Okay, so I have a trick that I taught my student. So sometimes it's very easy to forget. Is the inverse? Is the reciprocal of sine secant or cosecant, or is the inverse of is the reciprocal of cosine is secant or cosecant? So the trick is, remember, it is 4 syllable when they add them. So sine cosecant, secant cosine. So then you now will not forget how to distinguish which one is the which one. So 1 over x will be cosine theta, right? So we have cosine will be the adjacent side divided by hypotenuse. So 1 here, x here. And then using Pythagoras theorem, we have a number here we want to find. So 1 square plus question mark square will be x squared. So clearly, question mark will just be x squared minus 1. Okay, so tangent theta will simply be the opposite side divided by x. And what is theta? Theta, there are so many ways that you can express it. For example, if you use the inverse of cosine, it will be arc cosine of 1 over x, or simply we can just use the inverse of secant plus c. So this is the second example that, the third example that trig sub is actually needed. And in particularly, you can see that we need to use a lot of our knowledge about trigonometric identities and how to construct the triangles to help us to return to the original variable. But you can see that the format is the same. It's just after the simplification in the theta world, what kind of trigonometric integral you need to tackle, then you just do whatever you need to do, okay? Okay, so let's go to the fourth example. So this time in the square root, we have x squared minus 3 squared. So if you look at the table again, that will be the third row. So let's try to do it. So let x equals to, 3 squared, so a equals to 3, and then secant theta dx will be 3 times secant theta tangent theta d theta. Okay, so now we just do our 3 steps. First of all, we handle the culprit, right? So we have 9 secant squared theta minus 9. Essentially, we just plug in x equals to 3 secant theta. And then we also have x cubed, so that will be 27 secant cubed theta. Lastly, the differential. dx is 3 secant theta tangent theta d theta. So now, let me copy everything. Boop. So we need to simplify this expression. So how can we do this? Let's try to do some side work. First of all, we can pull out the 9. So we have secant squared theta minus 1. But what is secant squared theta minus 1? It's just tangent squared theta. Okay, so this guy is just 3 times tangent theta after you take the square root. So and then we copy everything. So now let's try to handle the constant first. So 3 times 3 is 9. 9 divided by 27 is 1/3. And then we have 2 copies of tangents. So we have tangent squared theta, right? Tangent times tangent. And then we have secant cube and then secant. But the secant cube is in the denominator. So 1 copy is cancelled. So we have 1 over secant squared theta. So now you need to ask yourself, like, hey, how can I integrate this guy? So let's try to make them into some more simple components. So first of all, tangent is sine divided by cosine. So tangent square will be just sine square theta divided by cosine square theta. And secant is the reciprocal of cosine, right? So 1 over secant will be cosine squared. Aha, now you see the cosine also cancel each other. So what we have is essentially just integrate sine squared theta d theta. So again, using our knowledge on how to integrate the square, the even powers of trigonometric function, we use the double angle formula. And then, because this is the second time we do this kind of integral, so I'll skip some step. That will just be theta minus 1/2 sine of 2 theta. So first of all, that's a little bit alarming, right? Sine of 2 theta, what is some trigonometric identities that is related to it? So the one that we need to use is sine of 2 theta actually is equal to 2 times sine of theta times cosine of theta. So now we can actually find it out, theta, and then the 1/6 and then the 2. Okay, so we have 1/6 sine theta cosine theta. Okay, so now what we need to do is to find back what is the sine theta, what is cosine theta, and again we use the same trick, right? So now we have x equals to 3 secant theta. So x divided by 3 will be secant theta. So 3 over x will be cosine theta. So now we can draw a triangle. Put it here. This is my theta. Cosine would be 3 over x. It's the adjacent side divided by the hypotenuse. So this guy, using Pythagoras theorem, this is just x squared minus 9. So the answer will be 1/6. So theta, we can do arccosine or arcsecant. So let's do arcsecant. X divided by 3 minus 1/6. So sine theta will be square root of x squared minus 9 divided by x. And then cosine will be 3 divided by x. So if you further simplify it, and then plus c, of course. So again, quite a handful, but it's the same flow. Okay, so now we go to the fifth example. So let's see, this time we don't see square root, but we see 9 over 2 power of something. So remember, if we have a fractional power, it's essentially some kind of root. And in particular, the half root is essentially just square root. So x squared plus 1, if you look at the table again, you see it matches the second one with a equals to 1, right? So again, we'll let x equals to 1 tangent theta, so just tangent theta then. Dx will be secant square theta d theta. So now we do our usual substitution back. The first thing we do is to do the culprit, right? So 1 plus tangent square theta, and then to the 9 half power. Okay, so and then we will also have the term that is not about the root, so we just plug in tangent theta whenever we see x. So we have tangent 6 theta plus 3 times tangent 4 theta, and then lastly we need to also plug in the differential, which is dx will become just secant square theta d theta. So now we need to further simplify this guy. So let's copy it, paste. So now what is this guy? So again, we remember 1 plus tangent square is actually secant square. So we can actually erase it and have secant square theta here. Okay, so again, the 2 and the 1/2 cancel out. So what do we have here? We'll have the integral of tangent 6 theta plus 3 tangent 4 theta divided by secant to the 9th power of theta times secant square theta d theta. Okay, so now secant 9 in the bottom, secant square in the top, we can actually cancel it. And then let's also expand my tangent in terms of sine and cosine. And then we have 1 over secant 7th power, which is just cosine to the secant power, cosine to the 7th power. So now we can distribute the cosine back in. So we'll have sine 6 theta cosine theta, I think, for the first one. Yes. And then plus 3 sine 4th theta cosine 3 theta d theta. So now you see that, hey, I'm not done yet, but this goes to something that we can actually calculate, which is some kind of trigonometric integrals. So how do we do it? So we try to eliminate the odd one. So we want to use cosine, because cosine to the 1st power, cosine to the 3rd power. We can actually use u equals sine, so du is cosine du d theta. So now let's try to do it. Let u equals to sine theta. Du will be cosine theta d theta. So this guy will be integral of u to the 6th power, right? Because that's sine. Yes, okay. So cosine will become the differential term. So we need to give one copy to the differential. Okay, plus 3 times u 4th, and then cosine square theta du. Hey, we want to go back everything to the UL, right? But we have cosine square, right? But don't worry, what is cosine square? Cosine square is just 1 minus sine square, and sine is u, so cosine square is essentially 1 minus u square. Okay, so now we can actually FOIL up the terms. And then we can further simplify 3u4 minus 2u6 du. Okay, so now I know how to integrate this guy, right? This will be 3/5 u5 minus 2/7 u7 power plus c, okay? But what is u? U is sine theta, right? So we'll have this as the answer. Of course, we're not done yet, right? Because the original integral is in the x world. So now let's see how we can go back to the x world. So tangent theta is x, which is x divided by 1. Theta here. So x, 1. So we'll have 1 plus x squared here, using Pythagoras theorem. So now what is sine theta? Sine theta will be x divided by 1 over x squared. So now we just need to plug this back in. And that will be our answer. A little bit complicated, but at least it's doable. And especially you see that the most challenging part of trig sub question is not the trig sub itself. The trig sub is quite standard. If you look at the table here, it's done. The story is done there. However, the trick or the difficult part comes to you here. Okay, you simplify your integral in the theta world, and do you know how to evaluate those theta integrals? Then that may require some your knowledge on trigonometric integrations. So this is the fifth example, which is I would say one of the most longer example, but at least it's still doable. Okay, let's do the last example of the day. So this one is quite refreshing. By refreshing, I mean scary, right? Because you see that there's a general quadratic, right, in the square root. And if you look at the list here, there's no 6x term, right? Like there's no x to power 1 term. So how can we do this? We need to recall something we learned in high school, which is completing the square. So let's try to do completing the square together, if you forget it. So x squared plus 6x plus 13. That will be x squared plus 2 times x times 3, right? And then plus 13. So if I need to make it a square, I need to have 3 square, and then plus 13 minus my 3 square, because I add 1 copy, so I need to subtract 1 copy, right? So we'll have x plus 3 whole square plus 13 minus 9, which is 4, right? 4. And in particularly, I will want to write as 2 square. Aha, see, now it looks like something on the table, in the table, which is the second one, but instead of x squared, we have x plus 3 square. So how can we slightly, can we change the substitution a little bit so that we can still use a similar strategy? The answer is yes. So I will let x plus 3, okay, to equals to my a tangent theta. So a is 1, right? 2. So 2 tangent theta. So that means x is 2 tangent theta minus 3. Okay? So now if you plug in back this guy into here, we will get 2 tangent theta whole square. So again, what is dx? Will be 2 secant square theta minus 0, and then the whole thing times d theta, which is because the derivative of constant is 0, right? So we just put 2 secant square theta d theta. So now let's try to plug everything back in. The first part, x squared, so we actually first copy the expression that we just do completing square with. This is a 2 here, plus 2 squared times dx. So we will have x plus 3 is 2 tangent theta, so we have 4 tangent square theta. 2 squared is 4, okay? And then what is dx? dx will be 2 secant square theta, and then d theta here. And again, we use the 1 plus tangent square equals to secant square, and then we'll have integrate 2 secant square theta divided by 2 of secant theta d theta. Let me check my math. Looks nice to me. Integrate secant theta d theta. So now this one is something that you need to remember. So this is actually natural log or absolute value of secant theta plus tangent theta plus c. Okay, so we need to do again some right angle triangle. Okay, right? So let's try to see. So we have x plus 3 equals to 2 tangent theta. So what is tangent theta? That will be x plus 3 divided by 2, right? So using SOHCAHTOA, this is x plus 3 divided by 2. So using Pythagoras theorem, we know that this guy will be x squared plus 6x plus 13. Okay, so natural log of absolute value. What is secant? Secant is the receiver of cosine, right? So we will have square root of x squared plus 6x plus 13 divided by 2. And then plus x plus 3 divided by 2. That is just tangent theta. Okay, plus c. So you see, the form is slightly different from what we get in the table below, but with a slight adjustment by shifting x to x plus 3, we actually can still do the usual trigonometric substitution. So I hope you can feel better about trigonometric substitution. It is always very difficult to learn it the first time, but if you do it again and again, you will also see the pattern. It's essentially the same routine to get you to some kind of theta integrals, and then you need to use your knowledge on how to integrate trigonometric functions and use your knowledge on right angle triangle to let things go back to the X world. So I hope you can succeed in your Calc 2 journey. If you like my video if you like my video and my cats, you can like this video, subscribe, and tell me what kind of math you want to learn. So peace out.